Hello, everyone. I'm Caterina. I'm a member of the rEView team. And today it's an absolute pleasure to introduce you to Dr. Alice Gualerzi. She's a board member of the Italian Society for Extracellular Vesicles and a team member of the LABION lab in Milan, Italy. I'll let her introduce herself a little bit. But thank you again, Alice, for your time and for the opportunity to speak to you.
Thank you, Caterina. Thank you for the invitation. It's a pleasure for me because I follow the podcast from rEView, so happy to be here with you. I am, as you said, a senior researcher in the Laboratory of Nanomedicine and Clinical Biophotonics in Milano, which is a particular lab because we are within a hospital, a research hospital of Fondazione Don Gnocchi, which is a hospital dedicated to rehabilitation of people with different type of chronic diseases. And I am a biologist, and now I deal mainly with biophotonics, but in the world of extracellular vesicles.
Yeah, so your background, it's pure biology, and then you shifted a little bit into like the more physical and physics of the research.
That's right. I am a biologist. I have a master's degree in biology applied to biomedical research, and I did a PhD on morphological sciences. So I am a microscopist as a background. And then I had an experience in a laboratory dealing with regenerative medicine. And then I started working here in Fondazione Don Gnocchi, and I discovered Raman spectroscopy, biophotonics, and nanomedicine all together here in the lab. So not studying, but just practicing.
That's so great to hear, yeah. And what about EVs? When did you end up discovering about them and studying them?
Well, actually, I discovered them quite late in my path because I arrived at LABION as a postdoc, and here I was dealing with the Raman spectroscopy of tissues. And while working on this project, it was about skin cancer. We started working with some collaborators who started talking to me about extracellular vesicles, and I was so fascinated by the topic that I proposed to my previous boss in the lab to start with vesicles and try to apply the methods that were typical of the LABION stuff on the vesicles. And it was incredible because it was difficult for me to introduce the topic, because as everyone who deals with vesicles knows that starting with them is not easy at all. But when we discovered that the methods that were here in the lab, which is a nanomedicine laboratory, so everything here is suitable for the analysis of extracellular vesicles, were actually the good ones to start with. And so I started to be fascinated by the fingerprint of vesicles by Raman spectroscopy, and this is how it started.
Yeah, so I know that now Raman spectroscopy has become kind of like a hot topic in studying EVs too. Do you feel like, what are their potential, its drawbacks, and what do you see it's going to be the future of Raman spectroscopy applied to EV research?
Mm-hmm. Well, when I started with the Raman of vesicles, I started with vesicles coming from cell cultures, especially from mesenchymal stem cells, because in my opinion, the easy way to start was something coming from reproducible cultures. So I started with them, and because I thought it was a potential quality control for the vesicles, because I don't know if you're familiar, but Raman spectroscopy gives you the biochemistry, the entire biochemistry of the sample. So you don't just look at one marker, but to everything which is inside your sample. And so I thought, well, maybe we can have an idea if the isolation is repeatable, if it is pure. And this is how it started. Then the potentialities of Raman spectroscopy became more and more apparent to me. And so we started analyzing vesicles isolated from biological fluids, in particular plasma or serum, because I am in a hospital. So my mission is to find something, a methodology, which is useful for the clinicians inside the hospital. And so it was nonsense for me to continue only with the cultures. It is important for sure, but I had the need also to look at samples coming from the patients. And I discovered that actually we could get so many information about the extracellular vesicles inside. I mean, I started with plasma, but then serum, saliva now. And so whatever you isolate them from, also peritoneal fluid, synovial fluid, we are looking to really different specimens. And it is informative. The point is that sometimes the information you get, it's so complex that you cannot really understand whatever you are looking at. And so you have to be careful not to to misunderstand your data. That's something which is difficult. And also as the way I use the Raman spectroscopy is a bulk characterization. I know that there are so many researchers who use it more specifically, highlighting some information using enhanced Raman spectroscopy to get information from specific components of your sample. I prefer to use it as it is and to look at the information overall. But this is the way I like it to use.
Yeah,
and it depends on the aim and the scope of your research, of course.
And so can you tell us a little bit more about what the LABION does, like every day with Raman spectroscopy, but even more in general?
Yes, as I told you, we are within an hospital. So we are asked to do some research which is useful for the patients that are inside our hospital. And people in Fondazione Don Gnocchi come here because they have neurodegenerative disorders or any kind of disability related to chronic diseases. And for example, we analyze extracellular vesicles from biological samples to find a profiling of the patient, to stratify them. For example, I work a lot with people with Parkinson's disease because you think about Parkinson's disease as a single disease, but actually every people is different. They have symptoms and signs which are really controversial sometimes. You cannot really understand everything about the person at first sight. And so sometimes the rehabilitation we can offer them has to be tailored to the personal need of the patient. And unfortunately, neurologists and physiatrists do not have the instruments to measure something that can tell them exactly which is the best treatment for that patient. And here in the lab, we try to develop methodologies that can tell them about a biomarker that is useful to monitor the progression of the disease, to profile the patient, to stratify them, and also to tell them possibly in advance if the treatment is the right one for that patient, if it is predictive of the effectiveness of, for example, rehabilitation. In particular, we work a lot in the so-called rehabiliomic, which is finding biomarkers for rehabilitation. It is a field in medicine where biomarkers are not really they do not exist, actually, because it has not been studied a lot. And but it's a urgent need because we are getting older and older as a worldwide population, and we will all need some kind of rehabilitation to improve our quality of life, actually. And so we use Raman spectroscopy to do so, to find a biomarker for rehabilitation, but also we use a lot another type of instrument, which is surface plasma resonance imaging. And that allows us to use a biosensor for a multiplexing analysis of the biomarkers on the surface of vesicles. Always to look for the best rehabilitation possible for our patient, to the differential diagnosis of complex patients.
And so do you collaborate a lot with clinicians and
Yes,
yeah.
exactly. Yes, it's an everyday discussion with the clinicians inside the
What,
hospital.
what what do they think about EVs? Did they know about EVs before knowing you?
Well, not. Maybe now the younger, yes, but when the LABION team started working with vesicles, they didn't really understand what we were saying. Not only because of the vesicles, but also because we analyzed them with Raman spectroscopy. So two kind of analyses which are quite difficult to be understood from people who are not working with them. But I have to tell you that when we started, they were quite suspicious. But now we are really collaborating with all of them because they understand the importance of what we do. We have tried to show them the results, the preliminary results that we have, because of course it's not easy to obtain our goal. But now they really trust what we do, and we have started collaboration on so many different topics. For example, also heart transplantation, respiratory rehabilitation, as I told you, Alzheimer, Parkinson disease, so many diseases. And they all ask us to collaborate, to discuss together which is the situation they see and what we can do to help them, and vice versa. So it's a continuous discussion, which is really fruitful.
Yeah, I can only imagine that. Yeah, that's so interesting also to me. I feel like more and more we're now understanding the potency and the many good things that EVs can bring us, even to like the real daily problems of patients in many diseases.
Yes. I have to tell you also that, of course, it's a huge field of research. As researchers within a hospital, we have to focus usually on something which is really translatable to the clinics.
Yeah.
Sometimes it is not easy to apply all the methodologies, the procedures that you see in the literature to the clinical case. Because the samples from the patient are so precious that you have just a few microliters sometimes of sample. You cannot waste them, but also you cannot do whatever you would like to do. So the difficult part is also to choose in advance by design which is the best procedure to apply to in your project, for example.
Yeah, I see, makes sense. And so, Alicia, I also wanted to ask you a little bit more about the Italian community. I feel like as a just PhD, I just received my PhD here in Italy. I felt like the EV community was really, really present. Whenever I needed something, there was like a senior researcher there for me. You were there for me, actually. We met during the first year of my PhD, and I asked you for help, and you were there. So this is like my vision. So on this side, but being the board member of the Italian EVIta, Italian Society of Extracellular Vesicles, and in general, being a senior researcher, what do you feel like it's the community here? And yeah, can you tell us a little bit more about the Italian community?
Yes, well, the Italian community is really a dynamic community. I have to tell you that I was honored when I was voted as a board member of the EVIta Society. I was not expecting that, actually, but it has been great to be part of the board until 2022. And we are dynamic, and also I think it's like being family. I don't know how to express it better, because whenever we meet together, it's always so relaxed to be there, but at the same time the scientific discussion is always really a fruitful discussion. You always hear about innovative topics. I know in my mind, they come just two of the many startups that have been founded by members of the EVIta Society, which are really brilliant scientists that try all ways to bring something new within the research we do in extracellular vesicles. And I have to tell you also that every time we have a workshop or a symposium, it's not easy to choose the oral presentations, because we have really high quality abstracts coming also from the young members. Luckily, the EVIta Society has a lot of young members who try to get involved, who desire to come, discuss, and also senior researchers, as you were saying. They are really open to discuss with everyone. There's no hierarchy in the society. We just want to share our knowledge and to try to do something together, to collaborate, to do something more. So I like a lot to be part of this community. I think the discussion we have are always easygoing. No one wants to do something against the other. We just want to collaborate and enjoy the time together.
That's so great to hear, and I felt the same. Yeah, I 100% agree with you. And can you tell us a little bit more about your role inside the EVIta?
Yes, as a board member, I am actually in the communication team of the EVIta Society. So I try to help with the website, the social media. Of course, we are not professionals. We do our best. But whenever we have to get in touch with other members to share with them, for example, we have a form where people looking for a PhD student or a postdoc, we share the open position in our website, and we try also to share with the community new publications, so that it's a way to get in touch with one another, because we have a lot to read, a lot to learn every day, and sometimes you can miss something, and so we try to keep in touch the members. And also we organize, of course, every year a workshop or a symposium, and I try to help also in this part. And I would like also to tell that this year we will have a call for the first starting grant of the EVIta Society. It is a small grant for young researchers that want to start an innovative project by their own, and so we will ask for applications in memory of one of our colleagues, Marina Kretic, who was part of the board member of EVIta Society. She was a brilliant scientist, a friend, a great colleague, and a mentor for a lot of young researchers. So we would like to have a good memory of her also by introducing this starting grant. It will be opened in a few days.
Thank you so much. Thank you for sharing this information and for sharing the memory of Marina. I haven't met her personally, but yeah, I've heard a lot of good things about her. So thank you. Few last questions are more about being a young woman in science. Being a young woman myself, I often find myself struggling between choosing between personal life and professional life. How did you manage to do that, if I can ask? And do you struggle sometimes, or it's always easy as it seems from the outside?
Of course not. I think that it's never easy to manage the private life and the professional one. It's never easy, but I have to tell you that sometimes we are even too worried about it. Sometimes it's just that you have to start and go and accept your limit. If you cannot do everything, we are not superheroes, so we do what we can. The important thing is that you do your best, I think, and I am a mom of 2 kids, so I can perfectly understand you when you say for a young woman starting research in Italy, which is well known as a difficult country to do research, but actually I have a lot of wonderful examples of women who are moms, who are great scientists, who then found their startup and they can do whatever they want because they are really self-confident and they just keep going. And I think everyone can do it. If we want, we can. It is not true that in Italy you cannot do it. You can, of course. You have to fight your own fights, but you can do it for sure. Be a scientist and a woman sometimes is more difficult, especially if you want a family, because you have to take care of yourself when you're pregnant, so you cannot go in the lab, for example. It's just an easy, simple thing that just slows down maybe your projects. But it doesn't matter. I mean, sometimes you just don't have to worry about go at top speed every day, because sometimes it's not even that part. The speed is not the good part of the job.
I agree.
You just have to take your time, even to stop thinking sometimes. Actually, when I had my children, I had more time maybe to study. And because I could not go in the lab, so I used that time to study, to learn, to think about projects. So you just have to change your mind and your habits, but it's not impossible.
That's great to hear. It's very encouraging. I feel also like having a strong community, both personally and like in the lab, having someone that respects you and wants you to grow, both professionally but also like personally. It's like a key to being successful in that case.
Yes.
But yeah, thank you so much for sharing your experience. And I feel like one last question, kind of a big one, I feel. What do you think would be one great discovery, or what is going to be the one thing that's going to change in the next future, and it's going to be like groundbreaking in terms of the EV research? I feel like you have talked a little bit about using EVs as biomarkers. Personally, I think that would be one big thing that is going to happen. But what do you think? Do you agree?
Well, in the field where I work, yes, not just finding a biomarker, but actually find the way to use the potential of EVs practically. Sometimes I feel that, unfortunately, we still have to struggle for the procedure, for the volumes that are not enough to have the signal we want. So if we will be able to solve the technological challenge and provide the researchers in the V field with something which is really translatable to the clinics, in my field, that will be the key point. So try to find a technology which is not that sophisticated that you cannot use it on the massive population. Because I think that extracellular vesicles in clinics have a potential that, of course, I mean, we all study them, so they have a huge potential. But at the moment, it's really expensive. The population you can test, maybe it's not big enough to have a robust biomarker, because you cannot test it on a huge population and a wide cohort. If we can solve this problem, I think that will be the key.
Thank you so much, Alice. It's been a pleasure. Hope you enjoyed.
Thank you, Caterina, for contacting me.
Thank you so much, and we'll follow your work.
Thank you.
Thank
See you
you
in Vienna, in Wien.
Yes, sure,
Nice
for sure.
2025.
Sure. Thank you. Thank you again, Alice.
Thank you.
Thank you.